Number 6, you have to write the prime factorization of 96. Prime factorization, the easiest way to do it is a factor tree. So what can you multiply together to get 96? Well, I know 3 can go into it 32 times. Then 32 can break up into 2 times 16. 16 is 4 times 4, and each 4 can break up into 2 times 2. So when I write my answer, I've got 1, 2, 3, 4, 5 2's and a 3. Or if you wanted to shorthand it, you could write it as 2 to the 5th power times 3. 12, you have to find the GCF of each pair of numbers. Well, do factor trees for each one. 55 is 5 times 11, which are both prime. 121 is 11 times 11, which are both prime. What they have in common is an 11. So the GCF is 11. If I wanted to find the GCF of each pair of those products, they have in common a 2 and a 2. So there's a 2 that's in common, there's a 2 that's in common. So the GCF is going to be 2 times, oh, here's another 2 that's in common, so I can multiply by 2 again. There's an x that's in common, so I can multiply by x. And another x that's in common, so I can multiply by another x. So when I multiply that all together, I get 4x squared. Number 6, you're doing 5x plus 9 times 5x plus 9. That's what it means to be squaring something. A lot of you like to do the box, so you can do the box method on this. I'm going to do the shortcut. The shortcut is I square the first term, 5x times 5x. I double the two terms being multiplied together, and I square the last term. So that's the shortcut. So if you recognize square of a binomial shortcut, you're going to get 25x squared plus 2 times 5 is 10 times 9 is 90x, and then 9 times 9 is 81. If you don't recognize the shortcut, you can do the box or double distributive. Number 8, if you want to do the box, you have to do x minus 6 times x minus 6. I'm going to do the shortcut. The shortcut for square of a binomial is square the first term. Since that's a minus sign, I'm going to write minus, double the two of them multiplied together, and then square the last term, which would be negative 6 times negative 6. So I get x squared minus 12x, and then negative 6 times negative 6 is a positive 36. Number 16, I recognize that as a special. I can just do first times first and last times last. So the shortcut is just 5x times 5x and negative 1 times positive 1. That only works because it's the same exact thing in each set of parentheses with just the signs being different. So I'd have 25x squared minus, and then 1 times 1 is 1. Number 12, first I would multiply together what's outside those parentheses. So I would do 5 times 1, m squared times m, and then n cubed times n squared. So that would give me a 5, add the 2 plus the 1 and get m cubed, add 3 plus 2, get n to the 5th, and then I would distribute that across 4m minus n. So you're going to do 5m cubed times n to the 5th times 4m. You're going to do a positive 5m cubed n to the 5th times a negative 1n. So I can do 5 times 4 and get 20. I can do m cubed times m to the 1st, add 3 plus 1, get m to the 4th, and then I still need to tack on my n to the 5th. Then I can do 5 times negative 1 and actually get a negative 5. So I'm going to put a negative here. And then I've got m cubed. And then I can do n to the 5th times n to the 1st and get n to the 6th. And then these are not like terms because the exponents on my variables do not match up perfectly. So that's as far down as I can go. Here I can do 7 times, there's really a 1 in front of that xy to the 5th. So 7 times 1 times 2. Then I can group the x squared, the x, and the x cubed. I can group the y to the 5th and the y to the 2nd. So 7 times 1 times 2 is 14. X to the 2 plus 1 plus 3 is going to be x to the 6th. And y to the 5 plus 2 is y to the 7th. 37, you're going to do 3x times 9x squared, and a positive 3x times a negative 4x. So 3 times 9 is 27. Add the 1 plus the 2 and get x cubed. 3 times negative 4 is negative 12. X times x, add the 1 and the 1 and get x squared.